Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 15, 2025, just 2 days ago. This paper introduces a new benchmark for LLMs in civil engineering and finds that even the top model, GPT-4o, fails to earn around 20 points on these supposedly simple industrial tasks. The paper is titled DrafterBench, Benchmarking Large Language Models for Tasks Automation in Civil Engineering. And this really highlights the gap between current AI and what's needed for real-world industrial use. Also, the authors shared their official implementation on GitHub. If you check it out, you'll find the full DrafterBench, including the evaluation data, source code, and instructions to run the benchmark yourself on different models. It's a great resource for anyone wanting to get hands-on with their work. So to make this more concrete, the authors provide a great visual example. It shows a simple drawing revision task, deleting some lines from a technical drawing of a wing wall panel. On the left, you see the correct workflow. Find the annotation, select the right lines, delete them, and then save the file. That save step is an example of an implicit policy, which is just an unstated rule that a human expert would know to follow. But on the right, you see all the ways an LLM can get this wrong, like deleting incorrect lines or even adding random new elements. So, building on that, here's the ideal workflow the authors envision for automating these tasks. It starts with an engineer or drafter who provides instructions and annotations on a PDF file. This is the pre-processing step. Then, in the automation phase, an LLM agent, you can see it visualized here as a brain lifting weights, takes these annotated files and automatically makes the revisions. Finally, in post-processing, a human performs an inspection. This whole process is what DrafterBench is designed to test. Specifically, how reliably that middle automation step can be performed. Okay, so to make this benchmark really comprehensive, the authors broke down the tasks in a very specific way. This table details the specifications. They created 1920 unique tasks in total, built from 12 core task categories. But the key here is how they varied the instructions. For instance, they tested the models with both complete and incomplete information, and with instructions that were either precise or deliberately vague. They even varied the language style. This systematic approach is crucial because it allows them to pinpoint exactly where models struggle when faced with real-world ambiguity. Moving to the results, this table shows exactly how several top LLMs performed on those different task sets. You can see models like OpenAI's GPT-4o, Claude 3.5 Sonnet, and others. Across the board, GPT-4o is the clear leader. But what's really telling is where all the models struggle. For instance, look at the performance drop when moving from tasks with precise details to vague details. That massive dip highlights how much these models rely on perfect instructions. The final comprehensive score for GPT-4o is just under 80, reinforcing that 20-point gap we discussed earlier. To dig into why that performance gap exists, this radar chart gives us a more granular view. It breaks down model accuracy across 6 different subtasks, things like defining arguments for a tool, calling the right function, or selecting multiple tools. Now, what's fascinating here is that for most of these individual steps, the models do pretty well. But look at plan execution on the left. There's a consistent major drop in accuracy for every single model. This tells us that while the models can handle the small steps, they struggle to maintain attention and execute the entire sequence perfectly. So to give you a better sense of what those plans actually involve, this table breaks down the 12 core drawing revision tasks. You can see they're organized by the type of object being changed, like text, tables, or a vector entity, which is just a technical term for the basic lines and shapes in the drawing. For each object, there are 4 main operations: adding, content modification, mapping, which means moving or scaling it, and format updating. This breakdown shows the fundamental building blocks that the models need to execute in sequence to succeed. So bringing it all together, what this research on DrafterBench really highlights is the gap between potential and reality. While LLMs show promise, even the top models like GPT-4o are still a good 20% shy of what's needed for reliable industrial automation. The biggest hurdle, as we saw, is that plan execution step, The models can handle individual actions, but struggle to maintain focus and complete a full, complex sequence. This benchmark gives researchers a clear target for future work. That's our roundup for today. Thanks for tuning in.